At the center of our solar system, the sun is burning bright and emitting a huge amount of visible light. But the surface of the sun has some dark blemishes on it, known as the sunspot. These spots are fundamental paradox of stellar physics. And to understand these sunspots, we have to understand the heart of solar magnetism and its influence on Earth. A typical sunspot presents two distinct regions, a dark inner core called the umbra and a lighter filamentary outer ring known as the penumbra. But they are not really dark. They only appear dark because of the comparison of contrast with the rest of the sun's surface. The sunspot plasma burns immensely hot at roughly 4000 Kelvin. But the rest of the photosphere, which is the visible surface of the sun, burns at around 5778 Kelvin. This thermal suspension happens due to a massive concentration of magnetic energy. Sunspot forms when powerful bundles of magnetic flux is generated deep within the sun's interior convection zone and then pushes through the visible surface. These magnetic fields are immensely strong. They can reach up to 0.3 Tesla in strength, which is thousands of times stronger than the Earth's ambient magnetic field. This magnetic field strength is crucial because it acts like a barrier. This barrier prevents the hot plasma from rising via normal convective motion. The magnetic pressure dominates the thermal pressure and overshadows the heat flow. Without the continuous influx of hot material, the region cools down and creates the umbra, which is the dark inner core of the sunspot. Sunspots are not static in nature. Their movements follow 11-year-long periodic cycle. This cycle is driven by the differential rotation, where the equator of the sun spins faster than the poles. This velocity gradient causes the magnetic field lines to become stretched, twisted, and increasingly tangled over the course of the cycle. This buildup of magnetic stress eventually leads to flux tubes breaking the surface and forming sunspots. The spots start to form at higher latitudes and eventually migrates towards the equator as the cycle progresses. This creates the signature butterfly diagram over the 11-year span. However, the complete magnetic cycle, known as the Hale cycle, is 22 years long. Ultimately, when these massive stressed magnetic loops reconnect, they unleash titanic bursts of energy in the form of solar flares and coronal mass ejections. When these ejections strike Earth, they interact with our planet's magnetosphere, which leads to geomagnetic storms. These magnetic flares create spectacular aurora, but also pose serious risks. They can overload our power grids, degrade the satellite electronics, and disrupt long-range communication systems. So the dark, seemingly tranquil spots on the sun are constantly reminding us of our delicate and profound connection to our active star. That's it for today, guys. Thank you so much for watching this video. If you enjoyed this video, then give a like, leave a comment and share it with your friends. And do not forget to subscribe to this channel for more videos like this in the future. I'll meet you soon with a brand new video. Till then, take care and bye.